Welcome to Manifested Publishers.
Hello learners, welcome to our lesson today. Remember the topic is still effect of an electric current on substances. And our lesson today, we are learning about electrolysis. If you remember in the previous lesson, we were learning about electrical conductivity of aqueous, of substances in aqueous state. To give examples of aqueous copper 2 sulfate, aqueous sodium chloride, aqueous hydrochloric acid, those substances. And we said that they are able to conduct the electric current because of the presence of mobile ions. And we said that positively charged ions migrate towards the negatively charged electrode, which is a cathode, and the negatively charged ions migrate towards the positively charged electrode, which is the anode. And I asked you in the assignment, you name the particles responsible for electrical conductivity in aqueous sodium chloride. And I hope that you've done that, and the particles responsible for electrical conductivity in aqueous sodium chloride are mobile ions. Mobile ions are the particles responsible for electrical conductivity in aqueous sodium chloride. In this lesson, we are discussing electrolysis. And I will start by defining three important terms we are going to use in this subtopic, electrolysis. And the first one is electrolysis. You see that electrolysis is a process of decomposing an electrolyte by passing an electric current through it. It is a process of decomposing an electrolyte by passing electric current through it. That is what electrolysis is. And therefore, that definition is now giving you another term which we are going to define, which is the electrolyte. And we say that the electrolyte is a substance which, when melted or dissolved in water, conducts an electric current and gets decomposed by it. Substance which, when melted or dissolved in water, conducts an electric current and gets decomposed by it. By it means it gets decomposed by that electric current. That's what we call an electrolyte. Therefore, electrolysis being the process of decomposing an electrolyte by passing an electric current through it, then electrolyte is that substance which, when melted or dissolved in water, conducts an electric current and gets decomposed by it. And if we have the electrolyte, then we have the third term, which is non-electrolyte. And a non-electrolyte is a compound that does not conduct electric current and does not get decomposed by it. Substance that does not conduct electric current and does not get decomposed. Compound that does not conduct electric current and is not decomposed is the electrolyte. Therefore, you need to understand, or you need to be able to define these three important terms: what electrolysis, electrolyte and non-electrolyte. Therefore, now getting into electrolysis, remember in the previous lessons, when we were discussing electrical conductivity of molten substances, when we were discussing the electrical conductivity in molten substances, we had a diagram like this. So this diagram is showing electrical conductivity in molten substances. We said that this is lead 2 bromide, and lead 2 bromide is an ionic compound. And for lead 2 bromide to be able to conduct electric current, then it needs to be melted. It needs to be melted. It needs to be in molten states, because when you heat, then the heat is now weakening the electrostatic forces of attraction, which are holding this ionic or these ions of lead 2 bromide together. Therefore, it needs to be in molten state. Remember again, we said that this an experiment like this should take place only in a fume chamber, because it leads to production of a red gas, which is, or red vapor, which is bromine gas. And bromine gas is very poisonous, and therefore it should only take place in a fume chamber. And therefore we said the equation for the reaction, or what happens when lead 2 bromide is heated. Lead 2 bromide, which is a solid, that is what you get. So when you heat lead 2 bromide, the heat is now weakening the forces of attraction, holding the ions of lead 2 bromide together, and to get lead ions and bromide ions. These ions, they now migrate towards the cathode and the anode. Remember again, in the previous lesson, we said that the negatively charged ions migrate towards the anode, while the positively charged ions migrate towards the cathode. And therefore, the positively charged ions, that is now lead, will migrate towards the cathode, and they will be deposited there. The positively charged ions are now attracted to the negatively charged electrode, while the negatively charged ions migrate now towards the anode. And therefore, lead ions will be attracted at the anode, while bromine ions will be attracted towards the anode, while the lead ions will be attracted towards the cathode, and they are now going to be deposited in those electrodes. Therefore, if we were to include the equations for the reactions, or what happens at both the anode and the cathode, then now the equations will be like this. So at the cathode, we are saying that the lead ions are now deposited, or get attracted at the anode, and they are deposited at the anode. Therefore, what happens when the lead ions migrate towards the cathode? The lead ions gain electrons. When they gain electrons, they're now deposited as a gray solid on the cathode. Therefore, at the cathode, the observation after some time will be a gray solid being deposited on the surface of the cathode. The lead ions gain electrons, and they're deposited as a gray solid at the cathode. And the equation is the lead ions Remember, the lead ions are now in liquid form, or they are in liquid state because they have been heated from at high temperatures from a solid then to a liquid. Then you're gaining 2 electrons because the charge is too positive. When the charge is too positive, it just means that they have to gain 2 electrons for you to be able to form electrically neutral atom. And therefore, lead metal is deposited. And this lead metal is gray in color. That's why we are talking about a gray solid being deposited at the cathode. Therefore, this is what happens at the cathode. You are having lead ions which are in liquid state. Those lead ions gain electrons, and they are gaining 2 electrons, and you are depositing an electrically neutral atom which is gray in color. And what happens at the anode? We have the bromide ions. Bromide ions which are negatively charged, they get attracted towards the positively charged electrode, and they are deposited there. And therefore, the observation after some time, you will see red vapor around the anode. And this red vapor is because of bromine ions being deposited. Therefore, what happens at the anode? The bromide ions, they lose electrons. Bromide ions lose electrons, and it's now deposited as a red vapor or a red bromine gas. And therefore, this is what happens. That is the equation at the anode. Bromine ions which are now in liquid form, they lose electrons. When they lose electrons, it is bromine, it becomes bromine gas. This bromine gas is red in color. It is just red vapor. Therefore, what is now observed at this anode is just red vapor around the anode. It is what is observed, and this is the equation at the anode. And therefore, that's what happens at both the anode and the cathode. Remember again, bromine is a nonmetal. Bromine being a nonmetal, nonmetals form ions by gaining electrons. Therefore, this ion, it has now gained, bromine has gained 1 electron to be in this state. Therefore, for it to be able to be in atomic state or in gaseous state, then it will have to lose electrons for it to be in this state. That's why we are saying that at the anode, the bromide ions lose electrons and is deposited as a red gas. And lead is a metal. Metals form ions by losing electrons. And therefore, this lead has already lost, or these lead ions had already lost 2 electrons to form these ions or in this state. And therefore, that's why it has to gain 2 electrons so that it is now deposited as an atom. I hope you understand that so clearly. Therefore, that's now what we are calling electrolysis, and that is what is happening at both the anode and the cathode. It is that simple. That is what happens at both the anode and the cathode. Therefore, we're now told to write the equation at the anode and the cathode, then I hope you can be able to write the equation. And again, I want you to note that they are in liquid, they are in liquid state. Lead ions are in liquid state, bromide ions are also in liquid state. It's not aqueous because it was a solid. This solid has been heated and these ions have been separated. Therefore, it's a liquid. It is not aqueous. Aqueous means when you add water, it dissolves in water. And you've not added water, that's why they're in liquid state. If you added water, then it would be in aqueous state. Therefore, that's what happens. Again, we are saying that lead to bromide, you need to heat at high temperatures so that you can decompose or you can separate the lead ions and the bromide ions so that now the electric current can be able to flow, because the ions or the particles responsible for electrical conductivity are lead ions, or they are mobile ions, which are now the lead ions and the bromide ions. Suppose we hand another substance apart from the lead to bromide. Suppose we hand a substance like sodium chloride. Suppose we hand a substance like sodium chloride. When sodium chloride is heated, therefore we'd expect you'll have the sodium ions and the chloride ions. They're in liquid state. That is what we would expect. Sodium ions and the chloride ions. And therefore, sodium ions, because they are positively charged, they will be deposited, they will be attracted by the negatively charged electrode, which is a cathode. And the chloride ions, because they are negatively charged, they will be attracted by the anode, which is positively charged, and they will migrate towards those directions. And therefore, the equation at the cathode would be sodium, which is in liquid state, will gain electron and it will be deposited as a sodium atom. Then at the anode, it would be chloride ions, which are losing electrons. When they lose electrons, it is deposited as chlorine gas. It loses 2 electrons. Therefore, the equation again should be balanced. Chlorine is an element in group 7 of the periodic table. Then for it to form ions, it gains 1 electron. It gains 1 electron. And then we now to be able to change from an ion to an atom, then it will have to lose the 1 electron, then to form an atom. But because chlorine will not exist as a free atom, it exists in the form of a molecule. Then that's why we have 2 atoms of chlorine. Then 2 atoms of chlorine, each requires 1 electron, and that's why each is losing 2 electrons. And sodium again, sodium is gaining 1 electron so that it can be deposited as an atom. Therefore, those are the equations you expect at both the anode and the cathode. I hope you can now be able to write the equations for what happens at both the anode and the cathode. It is that simple. Therefore, what I've said in this lesson, we have first defined three terms. One, we have defined electrolysis, and we have said that electrolysis is the process of decomposing an electrolyte by passing an electric current through it. You are decomposing this electrolyte by passing an electric current through it. Then that electrolyte, we have said it is a substance which, when melted or dissolved in water, conducts electric current and gets decomposed by it. The examples of this electrolyte include, we can have lead or molten lithium bromide, molten sodium chloride, molten magnesium sulfate, or aqueous copper 2 sulfate. Those are just examples of electrolytes. While a non-electrolyte is a compound that does not conduct electric current and is not decomposed. Like we give the example of a solution of sugar, a solution of urea. Those ones are non-electrolyte because they do not conduct electric current, both in solid, or both in molten and in aqueous states, because they lack the charged particles. Then we have said that this is a diagram now to represent or representing the electrical conductivity in molten substances. And we have said that if you have lead-2 bromide, then you need to heat. Heat needs to be applied. And the function of heat in this case is weakening the electrostatic forces of attraction, which are holding these ionic compounds together so that you can free the ions, and these ions can become mobile. And that's what has happened in both cases. And then we have now come to writing the equations of what happens at both the anode and the cathode. And we have said that at the cathode, which is negatively charged electrode, then positively charged ions are attracted towards the cathode. And once they are attracted towards the cathode, they migrate to that cathode and they are deposited at that cathode. For example, at this case, the lead ions will be attracted towards the cathode and they will migrate towards that cathode. Then once they migrate towards that cathode, then at that cathode, lead ions gain electrons. They are deposited as a gray solid. While at the anode, negatively charged ions, which are bromide ions, are attracted towards the anode. Then at the end, they migrate towards that anode. Then at the anode, bromide ions, they lose electrons. When they lose electrons, then they are deposited as bromine gas. And that's now what's happening. And that is what we have written at this case. Lead gains 2 electrons, which are negatively charged. An electron is negatively charged. Then lead metal is deposited. Then at the anode, bromide ions lose electrons, and a red vapor, which is bromine gas, is produced or is seen at the anode. Therefore, that's what happens at both the anode and the cathode. And this is also what happens at both the cathode and the anode when we have sodium chloride as the molten substance. Therefore, heat must be present. Heat needs to be present for that sodium chloride or lead-2 iodide to conduct electric current. And therefore, that brings us to the end of our lesson today. And I'm leaving you with this assignment. I have 2 questions. So that is the assignment. The first question is define the following terms. And the terms are 1, electrolysis, second, electrolyte, and third, non-electrolyte. Then the second question, write the equation at both the anode and the cathode when molten lead-2 bromide is used in an electric circuit or is used in completing an electric circuit. Therefore, ensure that you've attempted those questions before we meet in the next lesson. And in the next lesson, we will be discussing more examples on what happens on writing equations at both the anode and the cathode. See you in the next lesson.